Welcome to Study Loop.
This is the answer to Chapter 17, problem number 47 from the Smith Organic Chemistry textbook. This problem asks us, this problem talks about indene. And so we're told treatment of indene with sodium amide forms its conjugate base. And so we're asked to draw all reasonable resonance structures for the conjugate base and explain why the pKa of indene is lower than the pKa of most hydrocarbons. Okay, and so we have the conjugate base here. We were given it, and so we're basically just going to move electrons all around. So there's our first movement of electrons. So our lone pair will be there now. And our double bond will be here. And so we can then move these like this. So actually, let me scratch that. So actually what we'll do next is let's move the double bonds around this ring. So that's going to get us to here. So our lone pair still in the same place. And so now we'll move that lone pair like this. And these will go like this. So now our lone pair is at the top of the 6-membered ring. Now they can go here. This bond can break. So now we have this with a lone pair and a negative charge there. Now the electrons can move like this. It's going to get us to here with our lone pair and negative charge at that carbon at the ring junction. And so basically we'll just keep continuing to move electrons. So here and here. And then from here, and then back around to the 6-membered ring. So now the lone pair is here. And then this can continue moving around the rings. So now our lone pair is on this bottom carbon of the ring. And then did I skip one? Oh, I didn't skip one. I drew one too many. Sorry. I solved these ahead of time so that I'm not sitting here dumbfounded. Hopefully, trying to work through them. And even solving them ahead of time, I still made a small error. Okay. So now we have this, and our lone pair is back to where it started. But all the bonds in the left ring, the six-membered ring, have been shifted around. And so actually we can get rid of this last structure. I drew out one too many ahead of time in an effort to save time. And it has backfired nicely. Yeah, so these are the 11 resonance structures that we can draw. And the other thing that this problem asks us is to explain why the pKa of indene is lower than most hydrocarbons. And so one thing that you should notice about all of these resonance structures is that they have 10 pi electrons. And so because they have 10 pi electrons and they are fully conjugated planar ring systems, these are aromatic. And so the conjugate base of indene is aromatic. And so it's very favorable for it to be deprotonated because the conjugate base is so stable. And so remember, stable conjugate base equals strong or stronger, let's say, equals stronger acid. And so that's why indene is so acidic, because when we deprotonate it, we're making an aromatic molecule. And so that's very stable. And so indene itself is much more acidic than we might otherwise expect. And that's the answer to chapter 17, problem number 47.